v programu bylo napsané, že tato přednáška bude v češtině, tak se omlouvám, bude v angličtině. Doufám, že to nikomu nevadí. Welcome everybody. So this talk is going to be in English. I'm going to be speaking just a tiny bit about AWS. This is going to be quite a beginner's level talk. I wasn't really sure what's the usage of AWS around here, so I'll maybe try asking right away. So who from you from the audience is using AWS right now? Okay, it's not quite on point actually, it seems. Good stuff. So I've used my company's template for the presentation. So as you can tell, I'm working here locally in Tieto. I'm actually part of a Tieto industry solutions group called Oil and Gas. We're creating a specific software for oil and gas companies, and we have been selling them as boxed software. We have, however, decided that we're going to migrate with everything to AWS and offer those solutions as services to our customers. So I'm currently helping them with the migration to AWS. Previously, I've worked with Infor and Red Hat, and I have about 5 years experience on AWS. I've been serving as cloud architect for about 2 years now. Maybe clarification, cloud architect is a loaded term. I'm mostly solutions architect. So, this is not working. So, what is this talk going to be about? Basically going to throw in a little bit mixed bits and pieces here and there. I'll try to go through what are the possibilities of what can you do with AWS. Why should you probably care about it if you don't? And maybe as a bit of a disclaimer here, there is going to be a significant bias in this talk. I'm an opinionated person, especially around technology, and my experience is very much based on the fact that I've been working in corporations most of my life, and I'm coming from operations background also, so servers, hardware, networking, stuff like that. But I'm also very, very lazy, so I love automation, and AWS is my savior because I just don't want to do repetitive stuff. So that's why I'm there. So let's talk a little bit about the AWS and why should you care. So I think that most people know that there's also Azure and Google Cloud and lots of other different providers, but AWS is undoubtedly, at least now, the leader of the public cloud area. One of the baffling things, at least for me, and maybe should be also for you, is that the pace of innovation that the public cloud providers can do. I don't know about your company and what can possibly in your corporation, your central IT can do, but in Tieto, our central IT definitely cannot do that, because AWS, for the time that they have been in operations, have come up with more than 140 services. This depends on how you count them, but it's definitely over 140 with about 1,000 features and options. And just so you know how quickly they innovate, they have more than 1,000 product announcements during the year. I think that this year they might be aiming at 2,000 announcements, which means that every day you check their blog, there will be multiple announcements. So I'm working almost exclusively with AWS. I check all the news, and I cannot keep up. So if you're not paying attention, you will be lost very shortly. And just as a funky point, there has been more than 40 price reductions. So just consider if your service provider of any kind have ever come to you, oh, we're doing it so well, we'll offer you a lower price. So, yeah. So maybe you have a little bit of an idea why you should care about AWS from the service perspective. Lots of people know that you can run virtual machines there, but that's not really all that there is to it. I myself have started mostly on the hosting side, so you have your networks, you have servers, load balancers, what have you. But last few years has really seen an explosion of different kind of things that you can do. So you have stuff based around machine learning, media services, AI, desktop. They even made a new category for the AR and VR tools and stuff like that. So really, really crazy. I myself have decided that I'll be just keeping, up to date myself on just a few of those categories because I just can't comprehend all of them. So probably the biggest benefit for me of using public cloud of any kind, in my case AWS, is that I'm getting platform as a service kind of solutions, basically a managed service where I let AWS take care of some of my troubles and I don't have to care about them. The reason I do that is that I don't have to bother with the undifferentiated heavy lifting. What does that mean? Undifferentiated is that getting a virtual machine out there, automated, deployed, is something that every IT company has to do. And honestly, nobody cares about that. It's a normal thing. It's not a rocket science. So I don't want to be bothered with that. I have to do something to serve my customers, to actually earn my wage. So I let AWS do the heavy lifting, and I can focus on what matters to me. So using those kind of managed services, different ones for servers, for databases, actually gives you the opportunity to focus on your core business, your application, your service, whatever you do. The benefits for me are, of course, that you get there out quickly, you don't focus on the ops, and it's quite cheap. And the cheap doesn't mean it's for free always. Sometimes it means that the orchestration on top is actually free. You pay only for the resource. So let's say that you're running a database and it's managed by AWS. Quite often you will pay for such a service just what you would pay for that server anyways. So it doesn't matter where you host it, but you get that management on top. So here comes the benefit for you. But it doesn't always work like that. One thing is that also the global reach of the public cloud players. I know that it's always sad that Czech Republic is just a small pond looking in itself that nobody cares really about. But I think that is really good for you to think about the global future, possibly, if you're sitting in a startup that you want to take global one day, that you choose a partner that can actually get you to the world. So as you can see, all those green circles with numbers, those are actually regions where AWS is serving. And those lighter green ones are actually places where they will offer new regions, aka data centers. So as you can see, they are pretty much all over the world. Maybe an interesting tidbit of information is that if you're looking for really, really good coverage, go for Asia. They have even more. So unless you have clients in Greenland or maybe in Siberia, you should be fine. So if you look at it from the perspective of Europe, we're actually quite well served, considering that this is a US company. We already have 4 running regions. If we talk only about Czech Republic specifically, then the closest one for the latency might seem to be Frankfurt, but it's actually not always that one. Interestingly, you can get to London or even Ireland sometimes quicker. So before you choose your placement, don't always think about the physical distance. Internet works in mysterious ways, and especially tier 1 data providers, they will do weird things. So an interesting piece of information is that Ireland is the oldest region, and whenever there are new services offered, they are always first offered in US, and when they come to Europe, they are always offered first in Ireland. So if you want to be where the things are actually happening, go to Ireland. It's also cheapest, which kind of helps. So that's about the global reach and what you can do in Europe. So let's look at the development. Basically, you have decided you want to do your stuff on AWS. Where do you even start? There's a huge amount of services, constant update, lots of configuration, details, stuff. I'll try to show you that starting might not be all that hard. So to kickstart your development, you need help because how do you configure your development environment? How do you do CI/CD pipeline? How do you deploy the stuff out there? You know, there's actually quite a bit to do. So AWS, I think it was summer 2016, released this nice thing. They consider it a service, but it's more like a templating orchestration service for you. And CodeStart actually works like a shop. You waltz in there and you take a look and say like, I don't know, today I want to develop, for example, Python application on Flask with Flask framework, and I want to deploy this on a EC2 instance directly. And what CodeStart will do for you is that it will set up a whole thing for you. It will throw out a repository where you can manage your users with access to pull requests and stuff. It will create a continuous deployment pipeline even for some of the projects. And especially important point is that it will configure all the IAM for you, which is the most important thing because AWS has a really good security system in place called AWS IAM. And as good as it is, it's also very complex. So configuring it at least in the beginnings when you're starting with AWS is really complicated. So my honest recommendation, unless you want to create a huge security hole in your posture, would be to go for CodeStart. They will actually do it the proper way for you. As an example of what can you do, I'm not sure if it will be nicely visible, but this is a snapshot of the template that you can use actually. I've cut down the filtering on the side, so be Java, Ruby on Rails, Spring, whatever you have, you will most likely, the normal combinations you will find there. Of course, if you have some very, very weird combination of stuff, feel free to write an email to AWS, maybe they will accommodate you. And here comes probably the biggest recommendations of them all. This applies to any project nowadays, but I like to take it always when I can. So make sure everything you do is in code. Just don't deploy anything manually, don't configure anything manually. Feel free to do that for the first time when you're not sure how it's being done. But once you move past that POC stage, pilot stage, however you call it, go and drop it into code. Because otherwise, you're going to hate yourself. And trust me, I really hate myself every day because I'm running a project, well, about half of the stuff for different business reasons has been done manually, and it's the biggest pain in the world. And we're just doing everything right now to automate the rest of it. So talk with your management. If you're in a corporation, tell them that manual is not the way to go. It's 2018, so. As part of this, how to get that done? Basically, how do you drop everything into code? Maybe you're a developer and you do that for your application, of course, because there's no other way. But how do you handle the rest of that infrastructure and all the other stuff that's around? Most important concept would be the infrastructure as a code. I hope that somebody of you know it. So who knows, uses infrastructure as a code project? Well, not enough, not enough. With infrastructure as a code, what you do is that you take the programming experience and you write down in the source in a file, basically, this is how my environment should look like. I want there to be 2 servers. I want a load balancer in front of them, and I want this application to be deployed on that server. And basically, you can run that around. You can put their variables to names of those servers. So whatever you do, you can throw out a development, test, and production environment from the same code. So, as a practical example of what you should probably be using, bias alert, I would recommend HashiCorp Terraform, which is definitely not an AWS service or product. AWS has an own solution for templating your infrastructure, which would be AWS CloudFormation, but there is one big distinction. Terraform is actually driven by community and HashiCorp as a company, but they always, from the outset, had the plan to be able to orchestrate everything. So, do you like using Azure? Cool, you can. AWS also. Google Cloud? Yes, you can. Basically, whatever you can probably think of, which is normally used by people, you can orchestrate by Terraform, which is the big difference, because with AWS CloudFormation, you can orchestrate your AWS resources. But the trouble is, nowadays, you probably don't use only one provider for all of your needs. I'll show up for that later. So again, a very quick show of what can you probably do with Terraform. And again, this is not the full list. Terraform can partially orchestrate also itself, which is kind of funny. So whatever you're using, you can just use from one tool, which is very nice because you might have some part of the application in AWS, maybe you like some service from Google Cloud, so you use that together. But you have one interface for orchestration. So some of the deployment options for AWS, basically how do you get your applications running out there? And there are lots of options, of course. I'm not going to talk about all of them at all. This is focused on servers for first. So what will be the normal deployment methods nowadays? You can of course use the server, which would be the classical way. You just drop something you consider a virtual machine. You really like it, it's your pet. You install operating system, you manage that, you drop an application on top of it, and then you survive a lot of pain in the operations. If you're a developer, you might not care. Make sure that you have an operations team that is very, very far from you. Or you can go with something more reasonable nowadays, which would be containers. I haven't met that many applications that cannot be containerized. Keep in mind, our application has a Oracle database that its own image has 30 gigs of that Docker image. And it still works. And it's still better than do it any other way. So yes, we're using Docker image of 30 gigabytes. Still much better. The benefit, of course, with containers, split your operations, split your developers, everything is nice. Or you can go all the way and use function as a service, or so-called serverless. In case of AWS, that's AWS Lambda. Basically, you have only your developers writing the code, deploying that, and running that directly. So, there are multiple different ways to run containers on AWS. So what are these? From the level of desirability, you can do it yourself. You can just, again, drop out a EC2 instance, and then you can go and either, maybe even run the container on top of that virtual machine directly, if you like it. I don't. Deploy Kubernetes, Mesos, manually, whatever have you. But I would definitely start at this point, and that is managed container cluster for you by AWS. There are actually two solutions now. One is called EKS, and that's actually managed Kubernetes. What that means is that AWS will provision and take care of the hard stuff in the Kubernetes, the control plane. So the API, the ATCD servers, they will actually take care of that. They will keep them patched, they will keep them highly available, they will make sure they are stable. They do have quite a bit of experience of running stable software out there, so I would certainly believe them more than myself to keep that running. One disclaimer maybe for that is that it's a new kid on the block. It has been just released July 5th this year, so it might be lacking in functionality or some features right now. But whenever AWS released some kind of service, it has been always developed to be more feature-proof. Then there is also ECS, which is the custom orchestrator from AWS. So if you don't care if your containers are running on Kubernetes or whatever that is, you can even use ECS, which is very well integrated, but of course your Kubernetes tools will not work together with that cluster. So it's a consideration. And then comes the latest addition, which is called Fargate. And basically that's the complete abstraction of like complete paths. Basically you don't have anything, you don't even have servers. You just say to AWS in a file, like I want you to run this image from this URL, provide environment variables, and they will run that container wherever they please. It just works for you. But I think it was mentioned already in the previous talk, that's basically like a virtual kubelet. You pay for CPU and RAM hours. In case of AWS, it's for Fargate still hours. And it's pretty damn expensive for 24/7, exactly as you said. I do even prepared a comparison on Fargate. You can get 1/4 of a CPU core and 0.5 gigs of RAM for about $14. And a small virtual instance of 2 cores of CPU with 2 gigs of RAM will cost you 16. So very much a comparable price for a month. Very different amount of power available for you to run your project. So, but containers are really cool, but for example, I myself cannot really use containers everywhere I go, normally. So let's run a small example on a 3-tier web application, because I think everybody can relate to that. It's still something that is so widely used as a deployment architecture that it's just a standard thing. Later on, I will talk a little bit of how can that be done differently on AWS. So how does it usually look like in 3-tier web application? If somebody doesn't know, that you have users, they're hitting the web tier somewhere on the outskirts of your service. Then you have the application tier that's actually doing the application logic, and you're storing the session or user data in database. How that normally use this thing is that you would maybe have, this is a selection, don't be offended, you would have a Nginx on your web tier that would be serving the static content, and basically proxying stuff to the application server. Then you might have some Tomcat behind it, and then you'll have a PostgreSQL, for example, as a database. I like PostgreSQL. There is possibility to actually, of course, get that design into high availability state in certain ways, different configurations. But if you look at it from a general perspective, unless you use already something pre-prepared as a service from somebody, if you just go and install this on the servers, you will not get a serious API. You will have ways of instrumenting those things. For example, Tomcat, you can probably plug in something through JMX, do something with it, but it's not going to be really nice. Nginx is probably the same thing. You can do some on-the-fly reconfiguration, by changing the configuration file and reloading the server and doing all that kind of stuff. But at least I myself would not really want to do that anymore. So how would you deploy a 3-tier web application on AWS? This is of course a very simplified view, but you would change your load balancer for application load balancer, which is again magical managed service, which will do a lot of stuff for you. Some of the things that it can do for you is that, for example, you can take a provisioned TLS certificate from AWS, and AWS will handle for you a automated renewal. If you're using, for example, Let's Encrypt, it kind of works in a similar way. It's accepted by all the major browsers, but they are using different root certificate. So you can of course drive this through API. It has very nice settings. It's highly available. It will be there. It's very, very cheap. It doesn't cost even a quarter of a normal server. Then you would still have your server to run the application server on an EC2 instance. But at the end of it, you would have a database running, for example, on AWS RDS. And RDS is exactly that managed database service, which I really recommend all the people starting with AWS. Don't install your database on a server, because you have to install it, you have to operate it. And how do you take backups? You have a client that connects to the database and starts reading the data there, basically. So you usually have some global write log, or at least per table log, that really affects the performance. So if you, for example, have a write-heavy application and you want to take a backup, how do you do that? You know, it's always a problem. Work in RDS really help you on that point is that AWS has an ability to make a snapshot of the database from the storage level. They have a custom solution for that. Nobody knows too much about it, but it works. And basically what they are doing is that your database can run almost at full performance, and you can take snapshot every 5 minutes, and it can be even a write-heavy database. It really is crazy good. Good stuff is that for that you don't really pay anything, and you can use point-in-time restore. So you can, for example, have last 30 days, and you can select down to a, I think it's second level, where you can say I want to return to that exact time. Please do it for me. So that's very good. And quick run-up to a different service if you want to do something like a 3-tier web application. It's already been mentioned at the start. It's called AWS Beanstalk, and it's something that will help you get the application out there, get it running. Again, it's something like a templating service that just ties together the existing AWS Web Services for you. So basically go there and say, I want to run a Docker application on an application server, and I want a database behind it. What Beanstalk will do is that it will construct that environment for you without you needing to know all the details about those services, and it will run them for you. However, that would be quite too low of a thing of help. So what they added on top of that is that you can handle application upgrades. So this has been mostly applicable before everything was a Docker container, but you can also use directly the environment, which your code, you basically zip your, for example, Python application, you throw it out there, and they could handle the upgrade of that. What helps quite often to the developers is that they are handling a specially adapted Amazon Linux image for that, like an operating system. It's very similar to CentOS or Red Hat Enterprise Linux if you're using that. And they do the operating system patching for you. So you don't have to write automation, you don't have to think about it. You just configure, I want to have a maintenance window every weekend on Sunday at 4. They will restart and patch both database and the operating system for you. So you can really focus on your application without needing to worry that you're not really giving enough to the security. However, this is all the classical things that has been done in the data center. Here comes just the ideation of what can you possibly do if you take different AWS services in mind and you want to do a completely serverless website. There are of course different ways how to adapt it, but this has been something that I was able to quickly drop together. And basically with the power of how modern websites are created, you can basically, we ended up with clients running with most of their logic in the browser directly. So what can you do is actually get rid of all the servers and just publish all your static files, like be HTML files, pictures, JavaScript. You drop it to a object storage that you don't have to manage. You don't have to scale it. You don't have to think about it. You let your clients download directly over the internet all the JavaScript, start the execution of your, for example, interactive web page in their browser, and then you let all the interaction with the service go through, for example, REST API with API Gateway. There you can sanitize the requests, see if they're valid, if they're authenticated, and you can forward them to the Lambda functions. You don't run any servers, so basically whenever you have a request from a customer, it will spawn up very quickly, it will go through that Lambda, and you can, for example, just an example, you can use as a backend DynamoDB, which is a NoSQL database, but whatever has you. The benefit of this concrete design, as it is constructed, is that there is, aside no server, there is also no network to manage, because everything either works through API or through events directly. So it's very speedy, and you lose a lot of complexity and a lot of problems because they are just not there. So this would be quite a nice example. Also, the benefit is this web page will work the same way for 1 user, 10 users, and probably even 100,000 users. And you can do that scaling from, I don't know, at this moment I can have 1 user. In 5 minutes, I can have 10,000 of them. And I don't have to touch that deployment at all. It will just handle itself nicely. I double dare you, try to create a solution that can do that on a server or server-based deployment. So this is something that you can create on AWS quite nicely. If you are interested about this, because it was certainly very interesting for me, you can find ready examples on GitHub. I should probably be able to paste links to some of those interesting projects after the talk to the meetup page. So of course, not only by creating applications and just running them, you are alive. So, well, running over time already. Good. Okay, so I'll try to speed up just a tiny bit and select some interesting topics. Just a note, as I said, if you are good on my recommendations, you have all your infrastructure written down in Terraform, most likely, or CloudFormation or something like that. Don't be afraid to run aggressive testing in your CI pipeline. We are testing basically every merge on master branch. We're deploying the whole thing because it costs under $1. So I don't care if I do 50, 100 merges in a month, because I always know by the automated test if it even deploys. If it is so completely broken that it doesn't even deploy, I can already start solving the problem. If you don't know, you're lost, because how long it will take you for you to debug it. So the scalability of the resources is really nice. Use it. There are, of course, custom CI/CD tools, but funny fact, no matter how much I like AWS services, we're still using Jenkins. So props for that. Some notes for the operations, and this one is probably going to be pretty interesting if you actually run your stuff on AWS. Monitoring is an extensive topic that we could take a separate talk about, but what I wanted to convey most is especially this one thing, so you don't get lost in it. There is a CloudWatch. It's a service for monitoring within AWS. It will be there for you whenever you deploy anything. However, the trouble is, at least, that I would immediately recommend you to go out and take something different if you really need to monitor your applications, because CloudWatch is just not the right thing to use. Use it as one of your sources for data, but don't depend on it. Because one of the troubles is that CloudWatch, by general, gives you only information of what the hypervisor sees, basically. So it doesn't see into your virtual machines. So it doesn't even know what is your memory consumption, what is your disk throughput, whatever. It just doesn't know much. And you can implement it, of course, with it, but it costs money. And if you do it really properly, so I like to collect lots of metrics, usually 50, 60 from server. When you calculate the price, it will cost you the same or even more than a real monitoring tool. So go and probably buy a real monitoring tool. So some suggestions is for the guys that like to do it by themselves, use your Nagios, Sensu, whatever you like. I really like SaaS providers of monitoring. So there are some examples what you can do or take as your monitoring stack, but go really for a full solution. And last small topic is on security, because AWS released really nice and helpful services in the past few years. And I think that services really, especially lately, is so important. And they have added some good, easy security solutions. So the usual security solution, of course, is like a huge suite of functionality. Nobody knows how to configure it. You need a special person with lots of certificates, wanting God knows how many money. Not really too much for me. So they did a guard duty, which is security for dummies. I like that. What it does is basically takes in all the sources, standard sources from AWS, audit trail, logs from your network, and some additional sources. And AWS has a huge machine that basically uses machine learning to process those events. So they can tell you about stuff like, hey, on one of your servers, you have software that is on the network showing that it has an open CVE. So there's a vulnerability. You might want to fix that. Or somebody is doing a network probe, or even, I don't know, SSH brute force attack. So those are the classical things, but you can get that from most of the tools. What I really love is that, for example, from that audit trail, it will tell you that, for example, one of my colleagues used a VPN and was connected from the US, even though he's normally sitting in India. So when he tried connecting over that VPN from US, he actually arrived to a very different IP address than where he's usually seated. So that immediately triggered a critical alert for us that, this guy should not really be connecting from that physical location. It usually is a false positive. However, we already had one instance when one of our developers actually submitted his API key into a public repository on GitHub, and we didn't notice immediately. Thankfully, that key wasn't do anything really interesting, but still, that would be something that would really give you a nice fat alert that you would be able to actually handle very quickly. So this would be one of very big recommendations if you're using anything on AWS. This costs absolute fractions of pennies. So unless you have really big service, like you're using thousands of servers in AWS, you can enable for this, and it will probably not cost you even $1 per month. But it can save you. And then there is the last thing, which is a combination of automation and forcing people to do the right thing, which I absolutely like. So one of my responsibilities as an architect in our environments is making sure that our environments are secure and reasonably configured. Our operation team doesn't really share that kind of a view, so they're very keen on breaking all the policies. So in corporation, if you write a policy, it becomes a nice piece of paper. You can throw it somewhere on the wiki, and nobody cares, basically. So instead of writing policies on paper to be nice and lost for everybody, I decided to use AWS config, and I can actually force the people to adhere to those policies. I like that. So AWS config, basically, what it does is that it looks at your environment, and whenever there is anything changing in the environment, it will send an event. So with that event, you can always take a look. Is this something that should be happening or should not? If it should not be happening, you can always take an action. And since you can feed this into Lambda, you can have a small script that, for example, this guy is launching an instance that he should not be launching. So what can you do is that first you can delete that instance, and then you can disable his access. And send him an email, you should not be doing that. Problem solved, basically. It also integrates with the audit trail, so you can see a timeline of your resources, and basically it will show you what has changed and who has changed it. So whenever you're trying to find somebody who deleted that server because he shouldn't, it was a production, you will be able to find the name and see it. So that's the nice thing about that. So basically anything that you can write in an API or in a code that you can look at, you are able to handle with the AWS config. So that is nice. AWS, of course, has a library of existing rules. There are about, I think, 60 of them right now. Pretty reasonable. Most usually enable almost all of them. And there is a growing library, of course, of the open source ones. You can find some on GitHub and stuff like that. So find your sources. And I guess that would be it from my side.
Okay, so the microphone is dead, so I'll be just yelling. Do you guys have any questions? I checked the Slido briefly, there's no questions there, so please feel free to ask now.
And if you don't want to ask, I'll be somewhere around here taking refreshments, so feel free to come in and ask. I'll be happy to take on.
I have a question. You said that there is a different response time based on the location, and it doesn't always mean distance. Is basically the response time same for all the AWS services? Or, for example, it's better to hold something in Ireland and something in Frankfurt?
Well, that's a not easily answerable thing. The trouble is that this is not always in something that AWS can directly influence. Trouble is from where you were asking. There's actually quite a double separate industry that solves where and how to cache things around the world. So you get always a good response time. The general idea is that you should have an external monitoring somewhere where your users are, and you should take a look at what the actual numbers are that you're getting. There's quite a nice page, I think you can look for AWS latency. You will find some of the open source or basically project that some people created. They are continuously monitoring AWS latencies for different services in different regions all over the world. So you can get a pretty nice table that will show you what are the average latencies, what are the highest spikes versus the percentile 95, percentile 99. So you can really measure what you need for your application, for your use case, for your actually using it.
It works now.
You bastard!
Sorry. Any other questions? Don't be shy.
What's your monthly bill for AWS costs? Let's say that currently our unit with all our usage is hitting, we're somewhere around 50,000. We're having a lot of service. So yeah, it's even not that much. Maybe some fun fact, we have about 250 internal services in our corporation, and we looked at the costs, and we were paying about 100,000 euros a month. And when we just counted as his migration to AWS, we actually came to the conclusion that we will be saving half of that. we're pretty happy about AWS.
How do you see the common concept related to data privacy when it comes to migration?
Quite a useful thing. There are two answers. One is the theoretical one, the other is very much practical or empirical one. So the usual one that AWS will tell you is that you have different options for encryption or similar stuff protecting your data. As you know, GDPR basically requires that if you have any kind of personal data data, you have to encrypt. And since basically your username or your email address is already considered a personally identifiable data, we have to basically encrypt everything. So all our server space, database disks, transfers, even internal transactions are done over TLS. So we have everything encrypted. Of course, you can argue that the keys are in possession and the hardware is in possession of AWS. So I know that there are some companies that actually do something, they call it out-of-cloud encryption. Instead of putting the trust into AWS, you have a hardware key and encryption facility somewhere outside of the public cloud. And through different mechanisms for different services, but mostly just for servers, you're able to transmit data into the cloud that is already pre-encrypted with your own key that you have control of. At which point, it becomes a storage. AWS doesn't really know what's in that data anymore. They're running a server for you, but they have no way of getting into that data. So that's part of the theoretical question. The practical one is that in inflow and in general, AWS is servicing, for example, United States Department of Justice, Department of Defense. Lockheed Martin has data in AWS, Boeing has data in AWS. In the US, about 75% of hospital or medical facilities are storing the data in AWS. So for the type of data that we have to store on AWS, not so good.
Okay, if that's everything, so that's everything. So this is the end. There's one final keynote in, I think, 10 minutes, and then it'll be over, and the beers will start, to pour. And so thank you so much, you guys, for being here with us. I hope it gave you a ton. And yeah, thank you.